when we have already done what are elementary row transformations or operations, now let's see how to find the inverse of a matrix, how to find the inverse of a matrix, of course squared matrix, using elementary row transformations. The procedure is that you write the given matrix A, as IA. Continue to write A as such and apply a sequence of elementary row transformations till we get on the left the identity matrix I, and on the right side I changes to a new matrix B, and A we continue to write the same. So once we reduce it like this, then we can infer that A inverse is B. So what is the procedure of finding A inverse? That first we write A equal to IA, apply a sequence of elementary row transformations, I'll tell you how, till we get I equal to BA, then A inverse is B. Now please make a note here. Note, in case after applying one or more elementary row transformations on A equal to IA, if we obtained all the elements of one or more rows 0, all the elements of a row or more than one row 0 of matrix A on the left hand side, then A inverse does not exist. If we get all the elements of a particular row, one or more rows 0, we say A inverse does not exist. And now let me tell you, if given is a matrix A of second order, then what is the sequence of elementary row transformations to be applied so that we can get on the left hand side identity matrix? You know it is, let's suppose we have a squared matrix of order 2 as A, B, C, D. Then step 1 is to be applied on A. Step 1. What is step 1? That somehow you reduce this element A to 1. Either by dividing by A, or maybe sometime by interchanging the row 1 with row 2, or maybe dividing by A. Somehow or other you reduce it to A by using a proper elementary row transformation. That is step 1. Then in step 2, you reduce this C as 0. C should be made 0 in step 2. And then in step 3, by dividing it, whatever number in place of D you have, by that particular number, you reduce in place of D as 1. Get 1 here. And then finally, by applying elementary row transformations, you will see in the examples, step 4 will be to reduce B equal to 0. So that way, on the left, you will get 1, 0, 1, 0, 0, 1, the identity matrix, and then on the right side, you will get B into A, and automatically A inverse will be B. Now, let me take an example in support of it, of a matrix of order 2 by 2. Let me take an example. Note down the instruction. By using elementary row transformations, find the inverse of the given matrix. At present I am taking a matrix A of second order. Say the matrix is 2, 3, 5, 7. And by the way, this is question 4 in the exercise. Now, just see the steps to find A inverse. As I told you in the beginning, First of all, we write A equal to IA. That is, on the left you write actually A, the given matrix 2, 3, 5, 7. On the right side, you write I, because this is of second order identity matrix, but continue to write A symbolically till the last. That A will continue to write A on the extreme right. And now, see that we have to decide. There is no set rule to do all this. That how to reduce. What is step 1? The step 1 is that on the left, here, this number 2, we want to make it 1. As I told you, either I divide, row 1 on the left by 2 or multiplying by half. I can. But then, even 3 will become 3 by 2. That will be slightly complicated. Otherwise, what you do first of all, that you interchange R1 and R2. So you get in the first row 5, 7, in the second row 2, 3. Remember, whatever operation you apply on the left, the same has to be applied on the right. What happens, sometimes we forget to apply it on the right side. On the right side it will be 0, 1, 1, 0, and of course A we continue to write. And now, here this number is 5. If you subtract 2 times 2, 4, it will reduce to 1 and will not have any fraction. So the next operation is replace R1 by R1 minus 2 times R2. So 5 minus 2 times 2, 4 will make it 1, and 7 minus 2 into 3, 6 also makes it 1, and the second row remains the same. Apply the same operation on the right. That is R1 0 minus 2 times 1, that is 0 minus 2 will make it minus 2, and 1 minus 2 times 0 will not make any difference, will remain 1, and of course second row you continue as such and into A. Now, the first step we have got, that we have got A equal to 1 if it were ABCD. Now what is the second step? In second step we want to reduce this place, instead 2 we want to make it 0. It is simple, you apply R2 minus 2 times R1. This is to be done with the help of this one only. So R2 2 minus 2 times 1 will give you, see, you get here, the first row we are not changing. Remember, we are making the change only in R2, and we are changing R2 by R2 minus 2 R1. So R2 is 2 minus 2 times 1, that is 2, will make it 0. And similarly, here 3 minus 2 will make it 1. Do the same on the right hand side. You get 1 minus, the first row minus 2, 1 will remain the same. And for the second row, 1 minus 2 times minus 2, that is minus 4. So 1 minus minus 4 will make it 5. And then 0 minus 2 times R1, that is minus 2. So we'll make it minus 2, and A remains the same. So now we have got 2 steps. We have got 1, we have got 0. And by the way, automatically in the third step we wanted to make this number 1, which is automatically 1 there. The last step, we want to reduce this 1 by 0 with the help of this one. So what do you do? Now it's the simple operation that R1 minus R2. Replace R1 by R1 minus R2. So you get R1 minus 0, that is 1, that is not affected. 1 minus 1, 0, and of course second row is 0, 1. Now on the right side, we are doing R1 minus R2. So minus 2 minus 5 will make it minus 7. 1 minus minus 2 will make it plus 2, so 3. And of course the second row, that is 5 minus 2 will remain the same, and so will A. So now, do you find that I have reduced it to the form I equal to minus 7, 3, 5, negative 2 times A. And if you compare that, once I reduce I equal to BA, then A inverse is B. So safely I can conclude that the inverse of the given matrix A, that is A inverse, is minus 7, 3, 5, negative 2.